right, so we have another example where we are going to make a prediction. And so in our example, we say that the superintendent of a school district wants to determine the number of volunteer positions to have available for students. She conducted a survey where randomly selected teenagers within the district were asked, "Do you regularly volunteer?" Approximately 34% of the respondents said that they do not volunteer. If the district has 2,000 teenagers, about how many students regularly volunteer? All right, so this one is a little different from the ones that we've done before, where they gave us a part, they also gave us the whole, and we had to just go on and solve for the missing piece for the population. However, in this one, they give us the number of students that are not volunteering. And then they want to know how many students they can expect to volunteer. So, what I'm going to first start off with is out of 100, that's the whole, 100% of the students that are surveyed minus the 34% of the students that say they do not volunteer. That difference is going to be 66%. So, what that tells me is 66% of the students will volunteer. I'm going to say yes, they will volunteer, and no is going to be 34% of the students that are not volunteering. So, what we need is to figure out about how many of the students are going to volunteer on a regular basis. So, let's set up our problem. It's still going to be a part to whole. So, we're talking about a part and we're going to compare it to the whole. And so, our part is going to be the 66%. So, on this side, this is going to be our percentages. 66% of the 100 people that were surveyed. Um, and just remember, in order for us to convert 66%, you can put it over 100, which is the fractional equivalent of 66%. So we've got 66 out of 100 that will participate. And we know that the whole is going to be 2,000. So that's 2,000 students. And we're trying to find out what that 66% is going to look like. So we're going to put an X here. And so in this example, I'm going to use the fish method for me to solve. I'm going to say the fish method. And under the fish method, remember, you're going to start on the side that has the variable. You're going to start your fish. You're going to go diagonal, down, and then back up to the X, right? So this is your fish. And then it should be as easy as 1, 2, and 3 for us to find the value of X, okay? So the first step is we're going to multiply. Our second step, we're going to divide. Our third step, we're going to provide the answer. All right, so we're going to multiply. So we're starting from 2,000 and we're going to multiply that by 66. So if we take 2,000, multiply it by 66, we get 132,000. We're going to take this number and place it here. So now it's 132,000. And we're going to divide now. We're going to divide that by, for step 2, it was 100. And so you can divide by 100, but I also know that if I'm dividing, remember, as you move your decimal to the left, you're getting smaller, which means you're dividing by 10 every time that you move to the left. And if you move to the right, that means you're multiplying by 10 every place value that you move your decimal over. So since I am dividing, I'm going to go here. That means I'm dividing by 10. And then I'm going to go another one. And so that means that's 100, right? The way that I look at it is how many zeros do I have? And then that's how many places I'll move my decimal. So my answer should be 1,320. But again, you can go and plug that into your calculator. So we'll divide it by 100 here and see that I have the same answer, right? So now I'm going to take that 1,320 and what does this represent? That X was students. So this is the number of students that are expected to volunteer. So your answer should be 1,320.